This presentation is brought to you by Cyclone Power Technologies Incorporated, introducing the newest application of their Cyclone family of engines to the electric utility industry, microgrid solutions, thereby providing power from the sun every day and night. Almost 150 years ago, the electric utility grid was invented. It evolved into a complex network of power plants, transformers, and 450,000 miles of wire distributing extremely high levels of AC voltage. Since then, not a whole lot has changed. This outdated technology has many vulnerabilities. Lightning, high winds, rain, tornadoes, and hurricanes have wreaked havoc with it since the beginning. The grid is aging, and it would cost a staggering $5 trillion to replace it. A cyclone microgrid has the potential to change and greatly improve this. A microgrid is a local energy grid with control capability which can disconnect from the traditional grid and operate autonomously. The microgrid connects homes, businesses, and other buildings to a central power source, providing quality power and reliability. Microgrids have no utility tariffs, and solar microgrids can be tax credit eligible. The global microgrid market is projected to double from $12 billion in 2016 to $32 billion by 2021. Conventional microgrid systems employ diesel fuel generators. Some can include a small percentage of intermittent energy from renewable sources like wind power, photovoltaic solar, and biomass-powered generators. The wind and PV systems are DC power systems and require expensive batteries for storage and inefficient, dangerous, high-power rated inverters to provide the required AC voltage. Wind and PV systems are unpredictable because of the limitations of wind and sunlight. Therefore, a backup system beyond a conventional battery bank is required to generate electricity during those time periods. A diesel-fueled generator is generally used for this purpose. The Cyclone Power Technologies solar microgrid is more. It is 100% eco-friendly, employing sunlight. It uses high-efficiency parabolic trough collectors coupled with thermal storage unit containers to operate non-stop during the sunlight hours and the nighttime hours. The TSU system, using Cyclone's proprietary thermal transfer medium, will provide up to 5 days of sunless operation. During extended periods of clouded days, biomass and other clean energy sources can be used for unlimited operation. The Cyclone engine is a state-of-the-art, high-efficiency engine that produces no greenhouse gases and has an unprecedented long service life, and it will provide power from the sun every day and night. There's a diagram on the right of the screen here. A proprietary thermal transfer medium is pumped from the cold thermal storage unit through the Cyclone solar trough array. The TSU medium is heated to the optimum operating temperature and then stored in the hot TSU. The TSM's heat is transferred to the 1500 horsepower Cyclone Mark 10 engine to produce AC power. The cooled TSM is then pumped to the cold TSU, and the process repeats. Additional heat storage can be configured for supplemental heat for the TSM if desired to further extend the storage capacity of the TSU. Renewable waste incinerators, biofuel, recycled oil, and virtually anything else that burns can be utilized. The number of stored days of heat is limited only by the size of the TSU storage containers. 1 to 7 days of storage is realizable. The storage containers are designed to be installed at ground level or underground, thereby reducing the size of the power plant to an unprecedented, compact, and aesthetically appealing system footprint. In performance comparison, we're comparing the photovoltaic battery with the diesel backup capability to a standalone Cyclone solar power technology-based system. The energy collection is photovoltaic panels for the the photovoltaic system, and for the cyclone system, it is parabolic trough collectors. The energy storage for a photovoltaic battery is a battery, and for the cyclone system, it's thermal energy storage. The hours of stored generated power for photovoltaic with battery is typically 4 hours, which is 1/6 of a day. For a cyclone solar power system, it's 120 hours, which is 5 days, and that's typical. In comparison, the fuel to add an additional 4 and 5/6 days of additional electrical power to the backup capability of the photovoltaic system, you would have to crank up a diesel generator and you would burn 8,000 gallons of diesel. And in the Caribbean, diesel goes for approximately $3.49 a gallon. So it would cost you $28,000 additional to keep that system going. Now, comparing that to the cyclone solar power technology system, there is no expense to keep going for those remaining days. Feature analysis. The solar collector footprint. For photovoltaic power, crystalline silicon PV panels would occupy approximately 2.5 acres. Thin film PV solar panels would occupy more at 3.63 acres. It's about 100 square feet per kilowatt, and that's not including trackers. If you're going to put in the hardware and electronics for trackers on a PV system, you will end up increasing the footprint by 1 to 2 acres. For a cyclone power system, it's only 3/4 of an acre for the same amount of power, and that includes the tracking system. Energy storage facility footprint. Photovoltaic power requires a separate air-conditioned building. Size depends on battery bank and inverter capability or capacity. For cyclone power, the TSU containers are installed underground. Only a small non-air conditioned above ground structure is required for the cyclone power generator. High wind considerations. Photovoltaic power systems are extremely vulnerable to wind damage due to low density glass construction and are not suited for hurricane prone areas. PTCs for cyclone turn upside down and retract to the ground level for excellent wind mitigation properties. Operational status during storm activity. Well, it's for photovoltaic, it's battery storage dependent, which is approximately 4 hours. For cyclone, thermal storage dependent, and it's about 5 days. For floodwater considerations, photovoltaic power, the PV panels are mounted close to the ground in open fields and are susceptible to flooding and electrical damage. Cyclones PTCs have only thermal output and no electrical output. No damage occurs if flooding. The size comparison is impressive. For the same kilowatt output power capacity, a photovoltaic panel system is physically 3 times larger in area than the cyclone power trough system with underground thermal storage. Maintenance comparison. Maintenance requirements. Collection, medium cleaning. For photovoltaic power, there is an enormous amount of surface area comprised of acres of glass solar panels that need frequent cleaning. PVs cannot be turned off in direct sunlight and thereby pose a threat of electrocution during maintenance procedures. For cyclone power, the PTCs, they need frequent cleaning as well. However, there is much less surface area, and they are made of anodized aluminum framing and high-impact resistant panel construction and are much easier to clean. There is no electrical energy produced by the PTC, so there is no shock or electrocution hazard present. And cyclone also offers a self-cleaning system as an option. Maintenance of the storage medium. For photovoltaic power, batteries have a limited service life and are expensive. They will need replacing, and disposal is problematic. For cyclone, the TSU's heat transfer medium is inexpensive and environmentally benign. Maintenance requirement for power generator. The photovoltaic power system uses inverters, and they are solid-state electronic devices and are susceptible to component failure, electromagnetic pulse radiation, and lightning damage. For cyclone, the cyclone engine requires little maintenance with having only 7 moving parts. It powers a conventional high-efficiency AC generator that has no electronic components and is hardened against any type of electrical disturbance. In this slide here, we can see that the solar panels do fog up, they do collect dirt. And from talking to the industry, the practical application of this is every 2 weeks these things need to be cleaned. Safety issues with photovoltaic. In this slide we can see solar panels that have self-ignited. They weren't caused by external fires. These pictures are panels that actually burst into flames on their own. Is rooftop solar a viable and safe solution? The PV panel manufacturers would like you to think so. So one of these manufacturers has recently released a small PV panel the size and look of a roof shingle. They're designed to replace the existing roof shingles on a home and be aesthetically appealing as well as functional. Sounds pretty good, right? I don't think so. The problems. As long as the sun is shining, PV panels are always energized. There is no switch to turn them off. They are protected only by a layer of glass. If the glass is broken and water enters into the inner workings of the solar panel, lethal electrocution is a real risk. So, when homeowners or service people climb their roofs to clean the panels, they are exposing themselves to shock and/or lethal electrocution. There have already been in upwards of 400 people in the U.S. who have been severely shocked by their panels. Some of them have even been knocked off the roof to the ground by it. In California, there have been at least 2 lethal electrocutions by PV panels. As my old physics professor used to say, water and electricity don't mix. Fire safety hazard. PV panels can easily burn when damaged by flying debris or water intrusion. In a house fire, whether PV generated or not, superheated smoke and gases, which can exceed 1200 degrees Fahrenheit, rise to the ceiling and then bank down back to the floor. Just one lungful of this smoke can kill. Firemen cutting a hole through the roof at the highest point of the room allows the superheated gases and fire to rise out of the building, rapidly improving visibility as well as the survivability of the structure, and especially those trapped inside. This also allows firefighters on the hose line to advance inside and locate the seat of the fire and any victims. This vertical ventilation has saved many lives and valuable property. Besides actual rescue, this is one of a firefighter's primary responsibilities. In the presence of rooftop-mounted PV arrays, firemen will not perform this critical rescue method because of the risk of electrocution presented to them by the PV panels. This puts people's lives and their pets at risk. Is photovoltaic safe for the environment? The short answer is no. A new study by Environmental Progress warns that toxic waste from used solar panels now pose a global environmental threat. The Berkeley-based group found that solar panels create 300 times more toxic waste per unit of energy than nuclear power plants. Discarded solar panels, which contain dangerous elements such as lead, chromium, and cadmium, are piling up around the world, and there's been little done to mitigate their potential danger to the environment. So in summary, Solar panels and their arrays pose a significant shock hazard and electrocution risk. Another point is the number of accidents, shock, and electrocution from PV is alarming. Also, environmental impact by PV waste and disposal is a significant threat. The good news is that cyclone microgrids are 100% safe and friendly to the environment, and they will provide power from the sun every day and night. Here's an ideal application. Island countries have the greatest vulnerability to hurricanes and typhoons. The Caribbean region has one of the most active hurricane seasons on the planet. Problem: PV-based systems have a high level of mechanical complexity, thereby causing instability during storm time. The PV cells occupy large sectors of land and are manufactured from glass. They are fragile and are easily destroyed by hurricane winds, sending a spray of glass and metal shrapnel into the surrounding areas. The broken panels are still active in sunlight and pose a serious shock and electrocution risk during cleanup. This is a rendering of an island installation. It does not exist, but this is a rendering. And in the upper left, we see a cyclone solar trough array, and it's sitting on top of the TSUs, which are the storage containers for hot and cold heat transfer medium. And it prevents such a nice, aesthetically clean, appealing installation. The cyclone generator are housed in the little building there. That's right to the right of the trough array, and in there is the cyclone generator as well as an incinerator, which will provide backup heat generation. And this community here is completely autonomous. There is no grid in the islands for them to tie to, so they are totally dependent on the cyclone power generation system. And it will provide power from the sun every day and night. Microgrids offer an interesting business opportunity here. When you look at the profitability, comparing cyclone systems to diesel type systems, it's a very impressive, interesting study. So this hypothetical analysis assumes that the power generated will be sold at 75% capacity. The current rate for electric power in St. Martin is 38 cents per kilowatt hour. Starting with the conventional diesel generator system, the current cost of fuel in St. Martin is $3.49 per gallon. The maintenance and materials category to the left here designates a full-time mechanic and maintenance expenses. There's oil and filters and other things that have to be done with diesel. The annual gross profit realized at the bottom line there is a modest $120,843.82. Looking at the cyclone generator, which is at the top, with only 7 moving parts in the engine and no oil required to run it, maintenance expenses are considerably less. In addition, there is no fuel requirement and therefore no fuel expense. This affects the bottom line dramatically. The annual gross profit realized is an impressive $2.4 million. The next few slides are examples of how susceptible photovoltaic panels are to storm damage. The broken panels still generate electricity and sunlight, making cleanup a costly, arduous, and dangerous task. Here's Puerto Rico's power plant after Maria, which was somewhere between a Cat 4 and a Cat 5 storm. Totally demolished. All that glass and solar panel laying on the ground there. Here's another shot of their power plant. I can't imagine cleaning that up. U.S. Virgin Islands power plant after Maria. Same thing, Cat 4, Cat 5 type storm. The Cyclone Cat 5 tolerant design. The features of that are that the cyclone parabolic trough collector is designed to mitigate wind and storm forces, and the way it does it is before the storm event, each PTC is controlled electronically to invert itself. Upon completion of that invert cycle, the trough is then electronically lowered tight to the ground. The natural shape of the inverted parabola provides superior wind resistance properties. And then after the storm passes, the trough collectors return to their normal positions and resume normal operation. To summarize, the cyclone microgrid is indisputably the best solution for storm-laden island regions. It has the most efficient sunlight-to-power conversion technology and superior storm resistance design. It provides the first feasible technology to replace the conventional 150-year-old design-based wire above-ground utility grid. It has unprecedented environmental safety features unsurpassed by any other technology. Cyclone provides the most cost-effective and profitable solution. Only a cyclone has the power to stand up to a hurricane. We have one planet, and now we have one engine that will provide power from the sun every day and night. Thank you for listening and watching this presentation. Have a great, beautiful, sunny solar trough day.